Your Python service starts fine. 6 hours later, it's eating 4 gigs of RAM and crashes. That's a memory leak, and here's how you track it down. Start with the right tools. Python's built-in tracemalloc captures allocation snapshots. Take one early, another after heavy use, and diff them to see exactly where memory is growing. For live profiling on a running process without stopping it, PySpy sample stack traces in real time. And objgraph visualizes which object types are accumulating, showing you retention chains right in your terminal. Know what you're hunting. Circular references where objects hold references to each other prevent garbage collection. Unbounded module or class-level caches grow forever. Unclosed file handles and database connections accumulate silently. And C extension leaks bypass Python's garbage collector entirely. Be methodical. Reproduce the leak with a loop that simulates real load. Capture a tracemalloc baseline, let it run, then take a second snapshot. Compare the two to find the heaviest allocators. Then binary search your code by disabling subsystems one at a time until memory stabilizes. Don't overlook the garbage collector itself. Call GC. .collect to force a full collection cycle, then use GC. .get underscore objects to count everything the GC is currently tracking. If that count keeps climbing after every collection, you have reference cycles keeping objects alive. Enable GC. .debug underscore leak to log the exact objects involved. Profile with tracemalloc and objgraph, use systematic snapshots and inspect the GC directly. Prevent future leaks with weak references and context managers. Like and subscribe for more advanced Python interview prep. Want to nail questions like this in your next interview? Interview Mentor gives you hands-on practice with real questions. Every answer gets a grade with specific, personalized feedback. Track your progress across topics and difficulty levels.